Welcome to Selenetical Physics Volume 2, Reflections on the Electric Field. Having established that the only object with discernible features visible from every location on the surface of the Earth bears every location on the surface of the Earth as those discernible features, we'll now assemble the building blocks as to how the larger scale structure of our physical realm correlates with the moon projection, beginning with a primer on the electric field. A wave is not what something is. A wave is what something does. In the simplest terms, a wave is a motion or an oscillation of a material. In a transverse wave, the material is oscillating perpendicular to the direction of wave propagation, creating crests and troughs. In a longitudinal wave, the material is oscillating parallel to the direction of wave propagation, creating compressions, which are areas of increased density, and rarefactions, which are areas of decreased density. A sound wave is an example of a longitudinal wave. Electric fields are ubiquitous and practically synonymous with life, being present in all environments, as well as all biological organisms and many everyday man-made items. The electric field is an energy circuit, a union comprised of two essential components always, the magnetic field and the dielectric field. These are cross-sections of the electric fields of a single conductor in a system of conductors. The conductors are the black holes in the images, which act as poles of the circuit. In the single conductor, the poles are focused on the center, with one pole being behind the other. This is similar to the polar projection in Volume 1 of this series, where the North Pole is the center and the South Pole is the outer ring. In the system of conductors, both poles are represented by black holes. The circles propagating outward from the conductors are the magnetic field. In the single conductor, the circles are concentric. In the system of conductors, the circles are eccentric. The radial dotted lines are the dielectric field. The relation between the magnetic and the dielectric is the magnetic is parallel to the conductor and the dielectric is perpendicular to the conducting surface. This also means that lines of magnetic and dielectric inductive force are orthogonal or perpendicular to one another at all points. Lines of magnetic force close on themselves. They are divergent, expansive, and create space. Lines of dielectric force terminate on conductors. They are convergent, contractive, and collapse to counter space, becoming magnetism. An aid to understanding the concept of counter space is the eye of a hurricane. In the context of a hurricane, at this point of serenity in the center, around which the torrential storm rages, there is no hurricane. This zone of nothing that the vortex of the hurricane is focused around is counter space. Here, the cross-section of the electric field of a system of conductors is compared to a photograph of a magnet under a ferrocell. We can see the poles of the magnet are equivalent to the conductors. The shape of the magnetic field lines are clearly visible. What is commonly referred to as magnetism is actually the dielectric field. Magnetic and dielectric fields have the ability to shape and even contain plasma phenomena. When comparing the cross-section of an electrical circuit to the coordinate system on the moon, latitude is the magnetic field component of the electrical circuit. Longitude is the dielectric field component of the electrical circuit. The direction of material motion on Earth is best described as a westward circle. This is the direction the sun, moon, and other celestial etheric bodies travel in our sky. A wave propagating parallel to this circular westward motion is a longitudinal wave. A wave propagating perpendicular to this circular westward motion is a transverse wave. The lines of longitude, unsurprisingly, form a longitudinal wave with a compression just east of the antimeridian and a rarefaction just west of the prime meridian. These zones are also the maximum and minimum in the transverse interference pattern formed by the latitude. This means the Atlantic Ocean is expanded both laterally and longitudinally, while the Pacific Ocean is compressed both laterally and longitudinally. Similar to the electric circuit, where the dielectric field lines represent what is commonly referred to as magnetism, on the moon projection, the longitude lines represent what is commonly referred to as Earth's magnetic field. The transverse motion of electrical energy is represented by a field of eccentric circles rather than concentric circles. Energy is conveyed longitudinally, that is radially, from the primary pole to the secondary pole. The primary pole is north. Clearly demarcated is the collapse point of the eccentric circles of latitude and the radial intersection of the lines of longitude. Therefore, the secondary pole should be at the radial intersection at the other end of the longitudinal compression. It should at this point be noted that the longitudinal compression area corresponds directly to the deepest parts of the known ocean. The 7 deepest parts of the known oceans are in this area of the antimeridian Pacific Ocean: the Mariana, Tonga, Philippine, Coral, Kermadec, Bonin, and the Japan Trenches. Likewise, the Atlantic Ridge runs the entire north to south span of the Atlantic longitudinal rarefaction and is shallow ocean. More on this in Volume 4. The final prerequisite concept we'll introduce is one of curved reflective surfaces. Understanding this concept is vital to proper interpretation of southern latitudes on the full moon Earth projection and to deducing the large-scale structure of our realm. Curved reflective surfaces can be used to create distortions, as well as to resolve distorted images. Generally speaking, convex reflections are divergent and compress images along the axes of convexity, while concave reflections are convergent and expand images along the axes of concavity. In addition to this expanding effect, concave reflective surfaces have 2 very specific and relevant properties. 1, they reflect light inward and can focus that light, generating a source of intense heat, a locus if you will, at a particular distance from the reflecting surface. 2, they project images into the real world at a particular distance from the reflecting surface, known simply as real images. These real images are always inverted. This is not a coincidence. These concepts will be combined into a coherent model of reality in future volumes, after a full moon data analysis in Volume 3.